Greetings, ladies and gentlemen. In this video, we are going to answer this question. The question reads 20 grams of aluminium reacted with the 80 grams of sulfuric acid. What was the mass of the salt produced? So, the first step that we are going to take here, we are going to choose one of the masses given in order for us to find the mass of the salt produced. So as we can see, according to the question, we are given two masses. So to choose the mass that we are going to use to find the mass of the salt produced, we are going to identify the limiting reactant. So what is a limiting reactant? And what is an excess reactant? So a limiting reactant is the reactant in a chemical reaction that limits the amount of product that can be formed. The reactant will stop when all of the limiting reactant is consumed. So in a simple language, we are simply saying a limiting reactant is the one that will determine the amount of product to be formed. Or we can say the limiting reactant will limit the reaction. Let us also define excess reactant. So what is an excess reactant? An excess reactant is the reactant in a chemical reaction that remains when the reactant stops. The excess reactant remains because there is nothing left with which it can react. So our main area of concern here is limiting reactant. So we are going to identify the limiting reactant in order for us to find the, the mass of the salt produced. So before we identify the mass, before we identify the limiting reactant, let us consider this example here. As we can see, we are having two elements. We are having hydrogen and we are having oxygen. So two atoms of hydrogen are needed to react with one atom of oxygen to form one molecule of water. So as we can see, atoms of hydrogen are finishing first before atoms of oxygen. Hence, hydrogen here is a limiting reactant. Then oxygen is an excess reactant. Okay, so uh, now let us identify the limiting reactant between these two masses. We also need to understand that when acid reacts with a metal, salt and hydrogen will be produced. So as we can see, we are having aluminium metal and we are having sulfuric acid. So when these two react, salt and hydrogen will be produced. So we are having examples here. So sodium plus hydrochloric acid, we can see salt and hydrogen have been produced. Iron plus hydrochloric acid, we can see salt and hydrogen have been produced. Magnesium plus sulfuric acid, we can see salt plus hydrogen have been produced. And we are having this one, aluminium plus sulfuric acid. So this equation is coming from our question. It's coming from our question. Now it is time for us to identify the limiting reactant. So to identify the limiting reactant, we are going to come up with a balanced chemical equation. So we are reacting aluminium plus sulfuric acid. Aluminium plus sulfuric acid. So these two reactants will lead to formation of aluminium sulfate. will lead to formation of aluminium sulfate plus hydrogen according to the chemical properties of acids. According to the chemical properties of acids. So the next thing that we are going to do here is to balance this chemical equation. So let us consider each and every element in this chemical equation. So we are going to start with aluminium. So as we can see, we are having one atom of aluminium here. We are having two atoms of aluminium here. So what are we going to do next? Before we do something, so just in case there are people who don't know where this chemical equation is coming from, so aluminium is coming from group 3, hence aluminium is having valence 3. Then the uh, sulfate is having valence 2. Sulfate is having valence 2. So these 3 will come here and these 2 will come here. Hence we are going to have aluminium 2 sulfate. Then we are going to put sulfur and oxygen inside the bracket. So this is how we are coming up with this chemical equation. Now let us come back to our equation. So as we can see, we are having two atoms of aluminium here. So we are also going to write two atoms here. So as we can see, atoms of aluminium are now balanced. Here we are having 2, even here we are having 2. Let us also consider the next element, which is hydrogen. So as we can see, we are having 2 atoms of hydrogen here, and we are having 2 atoms of hydrogen here. So atoms of hydrogen balanced. Let us consider the next element, which is sulfur. Sulfur, here we are having 1 atom of sulfur. Here we are having 3 atoms of sulfur. Hence, there is need for us to balance atoms of sulfur. So what are we going to do? So we are going to write 3 here. Let us counter check. Atoms of sulfur 3, 3 balanced. Let us reconsider atoms of hydrogen. So here we are having 3 times 2 is equal to 6. So on the left part of the equation, we are having 6 atoms of hydrogen. Here we are having 2 atoms of hydrogen. So we are also going to write 3 here so that we can have a balanced chemical equation. So let us counter check 6, 6. So atoms of hydrogen balanced. Atoms of oxygen 3 times 4 is equal to 12. Even here 3 times 4 is equal to 12. The equation is now balanced. The equation is now balanced. So the whole essence of balancing the chemical equation, we want to make use of the molar ratio. So the molar ratio is the one that will be helping us to find the moles and to find the molar ratios. Okay, so you are free to pause the video and write this equation somewhere. I'm going to remove this equation so that I can create enough space. Okay, so we are having aluminium. We are having aluminium. We are having aluminium and sulfate. Sorry, we are having aluminium and sulfuric acid. We are having aluminium and sulfuric acid, and the ratio is 2 to 3 according to our balanced chemical equation. So we are going to leave our ratio in simplest terms. So we are going to divide by the smallest number. Here divide by 2, even here divide by 2. So we are going to have the ratio which is 1 to 1.5. So this is our normal ratio according to the balanced chemical equation. Now let us find the number of moles of aluminium. The number of moles of aluminium according to the number of moles of aluminium according to the mass given. So we are going to say the number of moles is equal to mass over molar mass So the number of moles is equal to the mass we are given, which is 20 grams. The molar mass, or the mass number of aluminium is 27. Is 27. So the number of moles of aluminium is equal to, so we are going to say 20 divided by, you are free to take your calculator and help us with the calculations. So uh, 20 divided by 27, we are going to have 0 0.74 0.7404, sorry, 0.74074 So this is the number of moles of aluminium. You can write this somewhere, so I am going to erase so that I can also calculate the number of moles of sulfuric acid. So this time around, let us also find the number of moles of sulfuric acid. So we are going to, first and foremost, we are going to write the formula, which is saying the number of moles is equal to mass over molar mass, is equal to mass over molar mass. So the number of moles is equal to the mass of sulfuric acid, according to the question, is 80 grams over the molar mass of sulfuric acid is 98. Is 98. So just in case you don't know where 98 is coming from, here we are having two atoms. Here we are having two atoms of hydrogen, and the atomic mass of hydrogen is 1. So 1 times 2 is equal to 2. Here we are having sulfur. The mass number for sulfur is 32 plus 32. Here we are having oxygen. The atomic mass for oxygen is 16. 16 times 4 is equal to 64. Is equal to 64. So if we say 2 plus 32 plus 64, we are going to have 98. So this is where 98 is coming from. Okay, so the number of moles of sulfuric acid is equal to 80 divided by 98. We are going to have 0 0.81632653. Okay, now let us come up with the new ratio. We compare it to the original ratio so that we can identify the limiting reactant. So we are going to start with the aluminium. Then here we are going to write the sulfuric acid. So we calculated the number of moles of aluminium, which is 0.74 0.74 0.742 to 0.816326. So let us leave this ratio in the simplest terms. So we are going to divide both sides by the smallest number, which is 0.74074. Even here, divide by 0.74074. So we are going to have the ratio, which is 1 to 1.1. So now let us compare these two ratios. We are having this as our original ratio and we are having this ratio. So here we were supposed to have 1.5. As we can see, we are having 1.1. So which means sulfuric acid is the limiting reactant. Hence, we are going to use sulfuric acid to determine the mass of the salt produced. So you are free to pause the video and write uh, this somewhere. So let me erase this platform so that I can create enough space. So we are going to use the mass of the number of moles of sulfuric acid to find the mass of the salt produced, which is aluminium sulfate. So sulfuric acid, to aluminium 2 sulfate, aluminium 2 sulfate. The ratio is 3 to 1. So we are from finding the mass, the number of moles, the number of moles of sulfuric acid, which is the 0.8163256263. Then here we don't know. Let us do a cross multiplication. So 3 times x is equal to 3x. 1 times 0.81632263. We are going to have 0.81632263. Here divide by 3, even here divide by 3. The value of x is equal to 0.027210883. So this is the number of moles. This is the number of moles of aluminium sulfate, which is the salt we are talking about here. Now let us find the mass, since we know the number of moles. So we are going to say the number of moles is equal to mass over molar mass. So we are from finding the number of moles of aluminium sulfate, which is the salt here. So we are going to write 0.272210883 is equal to mass. The molar mass of aluminium sulfate is 342. We do a cross multiplication. So we are going to say M is equal to 0.272108843 times 342. We are going to get 93.06 grams. So this is the number of this is the mass of the salt produced. So therefore we are going to, here is our answer, as we can see. So this is our answer here. This is our answer. So just in case you are unable to see, here is our answer, which is the mass of the salt produced. Thank you very much for watching this video.